When you drive a car, measuring speed is simple. You use kilometers per hour or miles per hour distance traveled over time. Easy. But the moment you step onto a ship or board an airplane, the entire system suddenly changes. Pilots and captains don't talk in kilometers per hour. They use knots. And that raises a weird question. Why are some of the most advanced machines on Earth still using a unit connected to literal knots in a rope? Modern aircraft have satellites, radar systems, and computers powerful enough to calculate thousands of things every second. So why are they still measuring speed using something created hundreds of years ago by sailors? As it turns out, the answer involves wooden ships, floating logs, sand timers, and even the shape of the Earth itself. To understand knots, you have to go back to a time before engines, electronics, or GPS existed. Back then, sailors crossing the ocean faced a massive problem. They had no way to accurately tell how fast their ships were moving, and without speed, navigation became incredibly dangerous. If you didn't know how fast you were traveling, you couldn't calculate distance properly. And if you couldn't calculate distance, you could easily miss ports, hit reefs, or disappear into the open ocean, completely lost. So sailors invented a surprisingly clever solution called the chip log. Sailors would throw a weighted wooden board into the water behind the ship. Attached to that board was a long rope tied with evenly spaced knots. As the ship moved forward, the rope would unroll into the ocean while another sailor flipped over a sand timer, usually around 28 seconds. During that short window, sailors counted how many knots passed through their hands before the timer ran out. 5 knots passing by meant the ship was traveling at 5 knots. That's literally where the term comes from. Ships were physically measuring speed by counting knots tied into a rope. But here's where things become much more interesting. The knots weren't spaced randomly. They were tied at very specific distances for a reason connected directly to the geometry of Earth itself. Sailors don't navigate using roads or flat maps. They navigate using latitude and longitude. The Earth is divided into degrees, and each degree is divided into 60 smaller units called minutes. Sailors realized that 1 nautical mile could represent 1 minute of latitude on Earth's surface, and that changed everything. Suddenly, navigation became dramatically easier because maps, distance, and the planet itself all matched the same system. If a captain needed to travel 1 degree north, they instantly knew that meant 60 nautical miles without any complicated conversions. This is exactly why the rope system mattered. Sailors calculated the perfect spacing between the knots so that the number counted during the sand timer directly matched nautical miles per hour. In other words, knots aren't random at all. They're mathematically connected to the size and shape of the Earth. But that still leaves another question. Why do airplanes use knots too? After all, planes aren't sailing ships. The answer goes back to the early days of aviation. When long-distance flying first became possible, pilots didn't have advanced navigation systems. They relied heavily on the same charts and coordinate systems sailors already used for ocean travel. Early pilots navigated using coastlines, stars, latitude, and longitude, almost exactly like ship captains. So aviation simply adopted the same navigation language. Even today, knots still make more sense for aircraft traveling long distances across the curved surface of the planet because, unlike miles or kilometers designed mainly for land travel, nautical miles naturally align with Earth's coordinates. This keeps navigation calculations simpler and more accurate over huge distances. So the next time you hear a pilot say an aircraft is flying at 500 knots, remember what that actually means. That speed system traces all the way back to sailors throwing wooden boards into the ocean and counting knots in a rope by hand. It's a measurement system so effective that even modern aviation never replaced it. And honestly, that's what makes human innovation so fascinating. Sometimes the smartest technologies survive for centuries, not because they're old, but because they were designed around the planet itself. This is Unlogic.